In today's video, before we get started here, just to let you know that this is a compilation video of asynchronous JavaScript videos that exist individually on my YouTube channel here. So this is just kind of compiling them all into one place. So, the transitions between videos might not be super crisp, but it should still get the job done. So hope you enjoy this. And I think, once you finish this video, you'll definitely come away with a really good understanding of how asynchronous JavaScript works. You're going to learn the difference between asynchronous and synchronous JavaScript. I know when I first started out, I would hear that JavaScript is a single-threaded synchronous language. But then I'd hear all this stuff about asynchronous JavaScript, and it wasn't super clear to me when I was kind of starting out. So this video is to kind of help you understand the difference between synchronous and asynchronous programming. So let's first talk about synchronous programming. And by default, this is how JavaScript is. But the key is by default, meaning this is the regular behavior of JavaScript, but it can perform asynchronous tasks. So first off, synchronous JavaScript, it's going to execute your code line by line synchronously from the top of the file to the bottom of the file. And since JavaScript is single-threaded and can only do one thing at a time, it is only going to hit one line, execute it, go to the next line, execute it, next line, execute it. It's going to go synchronously, one line after the other, all the way from the top of your file to the bottom of your file, and execute your code. And this is true whether your code hits a loop or kind of anything like that, a certain condition, it's still going to execute that code synchronously throughout your program. So here on line 24, I have a loop that is basically going to run 10 different times. And JavaScript is not going to move on to line 27 here before it completes this entire loop here. Because of its kind of synchronous default behavior, it's going to move line by line throughout this code and execute it line by line. So it's going to execute line 16, it's going to move to line 17, nothing there. It's going to execute line 18, so on and so forth. So if I run my code here, you're going to see that first, we're going to console log line 10, then line 12, then line 14. Then we're going to run this entire loop here, and then we're going to get to line 28. So if I run this here, you're going to see that's exactly what I get. I get line 10, line 12, line 14, and then for every iteration of my for loop, I log out what my iterable is, so 0 through 9 throughout that for loop, and then finally I hit line 22. So this is an example of JavaScript synchronous default behavior, just going line by line, one line after another, and executing your file from the top line to the bottom line. Now, JavaScript also supports asynchronous behavior, meaning it doesn't necessarily need to execute your code one line after another from the top of your file to the bottom of the file. It has the ability to run code asynchronously. And some different examples of this, which I will cover in future videos, are using promises within JavaScript, using the fetch API from the web browser, using set timeout, and different things like that. All of these are going to add asynchronicity to your code, and it's going to allow JavaScript to kind of get out of its default behavior. And we'll also have videos on the event loop and how all of this works in future videos, but this is just for an understanding of async versus sync JavaScript. And to just show you an example of this, on line 37, I'm just going to console log line 37, and then set timeout is an asynchronous function within JavaScript. It allows you to run some code at some later date. So since you aren't necessarily running the code within a set timeout right at that moment, it's asynchronous. You kind of set this code up to run, and then it runs at a later point in time. It doesn't run immediately. So you set this code to run, and then it runs later. So it's asynchronous. So in this set timeout call, what we're going to do is we're going to console log timeout running after 1,000 milliseconds or 1 second. And then here on line 43, we console log line 43. So what's going to happen here is JavaScript's going to hit line 37. Since console.log is a synchronous function, it is a space synchronous function, not an asynchronous function. It is synchronous. We're going to log out line 37. Then we're going to hit this set timeout function, and I'll go into this in future videos, but all you have to know right now is
this is an asynchronous function. So it's asynchronous, and whatever function we pass into set timeout, that is going to run after the specified milliseconds right here. So this console.log is going to run after 1,000 milliseconds. So as we go line by line throughout my code, we are going to console log line 37. We're going to hit this set timeout here, but we are not going to run this yet. We are not going to run this synchronously. Then we're going to go down here. We're going to hit line 43, and we're going to console log line 43. And then after 1 second has passed, we're going to come back and run console.log timeout running. Now, one tricky thing about set timeout is I could actually put 0 milliseconds here, and it would still run after all of our synchronous code has completed running, but that will be a little bit of a teaser for our set timeout videos and other videos on asynchronous JavaScript in the future. But as you'll see here, when I run this code, I get line 37, line 43, and then timeout running. Because set timeout is asynchronous, so we run this, and then we set our timeout to run this code after 1 second here. And then we run this, and then eventually 1 second will pass, and then we will run timeout running. So this allows us to run asynchronous code. All right, now why is asynchronous code useful? Well, JavaScript is a single-threaded language, like I mentioned earlier, so it can only do one thing at a time. Well, what if that one thing that you want to do, what if it takes a long time to perform that task? An example of this could be like a network request, or it could be some complex operation that has poor time complexity from an algorithmic standpoint, something that takes a long time. Well, since JavaScript is by default synchronous, you'd have to perform this entire task before moving on throughout the rest of your code. So you might have to wait for, say you had a slow network request, you might have to wait a couple of seconds before running the rest of your program. And do you really want your app to be paused and frozen for the user while all those network requests are taking place? Probably not. So wouldn't it be better if you could kind of schedule that network request to occur and then kind of wait for that request to complete and then run some code? Yeah, that would totally be useful, because then you kind of free up your single JavaScript thread, and a thread goes line by line throughout your code to run it. You would free up that JavaScript thread to then move on to other code. You can complete that synchronous code, and then you could come back to that scheduled task that you had and run that code. And it's going to improve the performance of your apps dramatically by being able to perform these tasks asynchronously rather than you needing to wait for a long network request or a complex algorithm to complete before running any other code in your application. So in JavaScript, by default, it is going to run your code synchronously. It is single threaded, so that single thread is going to go line by line from the top of your file to the bottom of your file and run your code one line at a time and execute it synchronously, one line after another. However, JavaScript does support asynchronous programming, meaning you can run your code synchronously line by line, but then you can also schedule some code to run at some later point in time. You can schedule it to run asynchronously, and you can do this using promises, fetch, timeout, and different things like that I'll cover in future videos. And this asynchronous programming is useful because you can free up your single thread in JavaScript to perform some other work instead of needing to wait for network requests to come back or complex algorithms and different things like that to finish before running anything else in your program. So coming soon, we will cover the event loop, async await, fetch, set timeout, promises, and a bunch of stuff regarding asynchronous programming. This is dramatically going to increase your skills as a JavaScript developer to understand how asynchronous programming works. So I definitely hope that you enjoyed this video and that you learned the difference between asynchronous and synchronous JavaScript. Leave any questions that you have below, and I will see you in that next one. In today's video, you're going to learn everything you need to know regarding promises in JavaScript. First, we're going to talk about what a promise is, and then we're going to talk about how to create promises and different ways to handle promises and some examples of doing so. So First off, what is a promise? Well, a promise is a placeholder for a future value. They allow you to perform asynchronous tasks within JavaScript. So, for example, let's say that you have a network request that takes a significant amount of time. Well, JavaScript is a single-threaded language, and if you had to wait for that network request to completely finish before doing anything else in your program, that would likely slow down your program significantly. And you can imagine if you had several network requests, well, that would make your program's user experience quite terrible. So a different way to handle this would be to be like, hey, okay, I want to kick off this network request to occur here, and when this request completes, then I want to handle whatever value it comes back with. So let's say that you're going to go get data from your database, and then once that data comes back, you want to do something with that data. Well, this is what you can use promises for. The promise is going to be a placeholder for that data that comes back. So you can kick off the network request, and then you can create a promise. And this promise is just going to represent, okay, we don't have this value yet, but once it comes back, then we want to do something with this value. And that promise is going to be kind of that placeholder for that value that it isn't here yet, but it's going to come in the future. So a promise is a placeholder for a future value, and it allows you to perform asynchronous tasks within JavaScript. Now, the actual representation of a promise in JavaScript can be thought of as just kind of a basic object. Now, every browser might have a little different implementation of like different types of promises and what's going to be on a promise when you do a fetch request and something like that. But you can use it very much so just like a JavaScript object. And a promise has 3 different states to it. So there's kind of 3 different statuses that a promise can have. And these are fulfilled, rejected, and pending. A promise is fulfilled when the data comes back to the promise, and now it has the expected value. A promise is rejected if some error occurs while you're trying to get the value. So if you make a network request and that network request fails, well, that is going to result in a rejected promise because there was an error getting that data. And then a promise can also be in a state of pending, meaning it doesn't have the value yet. So you make the network request and that request is still being made. It hasn't rejected, it hasn't fulfilled, it is still pending. Okay, so a promise is a representation for a future value. It's represented as just a JavaScript object, and it has 3 different states. Fulfilled, meaning the value has successfully returned to the promise. Rejected, meaning there was some error when trying to get the value. So like a network request, it failed and the promise is now rejected. And then pending, the promise hasn't resolved with a value, nor has it rejected. It is still going to get the value in performing that task. So how do you actually create a promise? Well, one thing that's important to remember is that you don't always have to explicitly create a promise to do this within your applications. And some functions return a promise automatically. So like the fetch function that you get to use automatically in JavaScript, that will just return a promise by default. And you don't have to explicitly create a promise and return it from fetch. It automatically returns a promise. Same thing with asynchronous functions. So when you create an async function within JavaScript, it's automatically going to return a promise. So there's certain functions that will automatically do this in which you don't need to explicitly create a promise. However, it's still definitely important to understand how they work. All right. Now, you can also manually create a promise. So if you want to perform some asynchronous task in your program, you can create your own promise and then either resolve or reject that promise depending on kind of what occurs while you're getting that value. And the way that you do that is you can use the promise constructor within JavaScript. So to create a promise, you can use the new keyword, and then you can call the promise constructor function that you get for free within JavaScript. You don't need to create this class or anything like that within your programs. You get this for free within JavaScript. And what you can do with this promise constructor is you can pass it a function. So here, I am passing this promise constructor an inline anonymous arrow function. It doesn't necessarily have to be an inline anonymous arrow function, but this seems to be the most common way that you'll see this done. So here I am passing a function as the argument to my new promise constructor function. And what the promise constructor function does is it's automatically going to pass me two different arguments to my function that I pass in as an argument to the promise constructor. And these two arguments are going to be a resolve and reject function. So argument number one to my inline function that I pass in here is resolve. And this is a function that allows me to resolve my promise. And then the argument number two is reject. And this is a function that allows me to reject my promise. And then within the body of my function here, I can write some logic and then either resolve or reject my promise depending on different things that happen. So in this example here, in the body of my inline function, I'm setting a count variable to 5. And then within the body of this function, I say if my count is less than 10, I want to resolve my promise. Else, just reject it. And this new promise constructor here, it's going to return a promise. So I'm assigning my constant p to be a promise that's returned from new promise. Okay, so this is going to be a placeholder for my future value. And it's either going to resolve or reject my promise depending on what happens here with my count. Now, how can we handle when our value either resolves or rejects? Because right now it's just a placeholder for a future value. Like if I made a network request, well, I don't have this value right away. So how can I perform some action with the value that comes back? Well, that's where you can use the functions .then, .catch, and .finally. So on a promise object, you can access three different methods, .then, .catch, and .finally. And those allow you to handle your promise value when it either resolves or rejects. Looking at it here, the way that these work is I use my promise and then I access the .then method on my created promise here. So I do p.then. And then what I can do here in this .then method is I can pass it a function. And this function is going to run when my promise fulfills. So here I pass in an inline function here to my .then method, and I console log my promise, and I just console log the string fulfilled. And this .then code, it only runs if your promise fulfills. It will not run if your promise rejects. So if I comment out my .catch block, which I will cover in just a second, and I just run this .then code, and if we look at the logic of my promise here, well, my count is 5. That is less than 10, so my promise should resolve here, and that is going to run my .then block, because .then methods are going to run the function that you pass into them once a promise resolves. So if I run my code here, you're going to see that my promise is undefined because my promise really doesn't have a value to it. Like I don't resolve my promise with any value, but I'll show you that in just a second. And then I get console logged fulfilled. So I do run this block of code, and you can see this promise is represented by just an open pair of curly braces, just a JavaScript object. Now let's handle if the promise rejects. So the way we can do this is we can use a .catch block because you're catching the error that occurs. So your .catch works the same way as .then does. And I'm chaining my .catch onto my .then here. It might make it a little bit more clear if I just put it right here after the closing parenthesis of my .then block. And the reason I can do this is because the .then and .catch methods, they return a promise themselves. So .then automatically returns a promise, which allows me to just kind of chain on my .catch block. Okay, so .then and .catch automatically return a promise themselves, which allow you to do this kind of chaining of promises here. And the way that .catch works is the same way .then works. You pass in a function to run when your promise rejects. And it's important to remember here as well that .catch it only is going to run if my promise rejects. It will not run if my promise resolves. And the opposite is true for .then. It only runs when my promise resolves. It does not run if my promise rejects. So in my code right now, my logic will still make my promise resolve, which means that we won't run this .catch block yet. So you can see I just get my promise, it still has no value, and then I still get my fulfilled console log statement. But if I change my logic here and I set my count to 12, well, now my count is not less than 10, so it's not going to resolve here, but it's going to reject. And what's going to occur here is once it rejects, well, I'm not going to run any of my .then functions, so I will not run this passed in function to that .then, but I will run my .catch block. And if I run my code, you see that my promise, it now has this kind of rejected marker to it, and I console log out rejected. So this represents a rejected promise, and I console log rejected because my .catch block is what will run when a promise rejects. Now, there might be a situation in which you want to run some code regardless of whether the promise resolves or rejects. And that's where you can use a .finally block. So .finally, you can chain it on to your .catch and .then blocks, and this is going to run no matter what. It's going to run if your promise rejects, and it's going to run if your promise resolves. In either case, your .finally block is going to run. And I think that a very common example of this is like if you're making a network request, you might have some state in your program that is set to loading. So you're loading that request. You don't have anything to show the user yet. But regardless of whether your request fulfills or rejects, you're going to want to set that loading state to false in either case. And this is where you might use a .finally block. In either case, your request is done. And you can set your loading state to false. All right, so let me show you here an example of this working. So my promise is still going to reject here, but I would expect us to run this .finally function that we pass into .finally. So the API of .finally works the same as .catch and .then. You pass it a function to run regardless of whether the promise resolves or rejects. So I would expect this code to run even when I have a rejected promise here. And as you can see, it definitely does indeed run. It console logs my promise, which is still going to be rejected. And then here it console logs finally because we enter this finally block. And then also since my promise rejects, we definitely run my .catch block as well. Now, if I change my logic, so my promise resolves here, you're going to see that my .finally block still runs, but it's going to run after my .then functions run. So here I run my .then block, which is console logging fulfilled, and then I still run my .finally block. Okay, so .finally, the functions you pass to it are going to run irregardless of a promise resolving or rejecting. Now, I already talked about how .then and .catch return a promise, which allow you to kind of chain on these promises here. So I could even chain on more .then. So I could do .then, perform some action that's going to return a promise, and I could add a .then to that and kind of continuing down that chain. All right, so .then and .catch automatically return a promise, which allow you to chain on the .then and .catch methods. Because if it returns a promise, you can access the .then methods on the returned promise. Now, promises, they often resolve or reject with some value. So a promise might reject with an error, some object representing that this whatever task you try to perform, it didn't work. It resulted in an error. And then they might resolve with some value. So if you make a network request and that data comes back successfully, well, it's probably going to resolve that request with that data. So in my logic here, and I'm going to get rid of my .finally function just to make this a little bit more clear. I'm going to resolve my promise here with a value. And here, I'm going to just resolve my promise with a string resolved. So how do I access this value within my kind of .then block? Because my .then block, it's what's going to run when my promise resolves. Well, if you resolve a promise with a value, you can access that value as a parameter to your passed-in function to your .then method. So here, I can accept a value as a parameter. And instead of console logging fulfilled here, I'm going to just console log whatever value is resolved by my promise. So I'm resolving my promise with this value here, which is automatically going to be passed in to my .then method, which I just console log out here in the body of this function. And if I run this, you're going to see that when I console log my promise here, so on line 54, when I console log that, my promise, it actually shows a value here. It has the value of resolved. And then I also console log my value, which is resolved, because it's automatically going to be passed in as an argument to my value parameter, and I just console log that out here. And you can imagine that this is going to be very useful in the case of network requests as well, as when that data comes back, well, you probably want to do something with that data, and the way that you're going to do something with that data, or the way you're going to access that data, is it's likely going to be passed automatically to your .then method, just like this is here. So like the fetch method, it will automatically resolve your promise with the data that comes back from your network request. And that data can be accessed right here. So in a network request, this might be an object of data, and you might access your value right here. And then you could perform some task within your .then method because that data was resolved in your promise here. Now, the same can be true for the reject method. You can reject a promise with some value, and I can access it the very same way here in my .catch method. And I'm going to just console log my value here. And if I make sure my promise rejects here, and I run this, you can see my promise, it now represents a rejected promise. So I'm console logging my promise here, and it is now rejected, and it has the value of reject because I reject my promise with the value of reject. And then I also just console log my value here on line 58, and that yields reject. Because when I reject my promise, it works the same way as resolving it. I reject it with this value right here, which is going to be passed in as an argument to my function that I pass in as an argument to my catch method. And then I just console log that value right here. So that gives you the fundamentals of promises in JavaScript. Now, there's definitely more to talk about when it comes to asynchronous JavaScript. I'm going to have future videos on the Promise.all, all settled, and those different methods that can kind of work on promises. And then we're also going to touch on async await, the event loop, and different things like that. So I hope you enjoyed this video and learned a ton about promises here. Let me know below if you have any questions about promises, and I'll catch you in that next one. In today's video, you're going to learn everything you need to know regarding Promise.any within JavaScript, not to be confused with Promise.all, all settled, or Promise.race. However, we will discuss the differences between all of these methods. All right, so we're going to start with kind of a conceptual explanation of how Promise.any works. Then we'll get into some examples so it becomes more clear how it works. And then we'll discuss some specifics on how it's different than some of the other promise methods like all settled, and race. So moving back up to how this method works. So this method, it takes an array of promises. And what it's going to do is it's going to return the first fulfilled promise within that array. So you pass it an array of promises, and it returns the first fulfilled promise. Now, it will ignore any rejected promise. So even if a promise rejects, it will just kind of ignore that and will return the first promise that actually resolves successfully. So this method is useful for returning the first promise that fulfills, but it will short circuit after that promise fulfills, and it will not wait for other promises to finish. And it will also just ignore promises that reject, and will just continue to wait for the first promise that successfully resolves and return the value of that promise without waiting for any other promises to resolve. All right, so let's look at some examples of how this works here. So in my code here on line 18, I just create a promise that rejects with the value of 0 using the Promise.reject method. And then on line 19, I create another promise, and I have this promise that resolves after 100 milliseconds. And then on line 21, I have another promise that resolves, but that will resolve after 500 milliseconds. So the first thing that's going to happen is promise 1 is going to reject, then promise 2 is going to resolve, and then promise 3 is going to resolve. And then I put all of these promises within an array here on line 24. So I put promise 1, 2, and 3 within this array. And then I use the promise object. So an object that you get for free within your programs. You do not need to create this anywhere. You can use this object for free. And then I access the .any method, and I pass in my array of promises. And then to handle the return value of the .any method, I use a .then function because the .any method is going to return a promise of the first value that resolves within my array of promises. So I can chain on a .then, and I just console log the value that resolves. And then I also, if something rejects, I'll just console log rejected. So if I run my code here, what you're going to see is I get quick. Because in my array of promises here, the first promise that successfully fulfills is going to be the promise with the value of quick, because it's going to ignore this rejected promise right here. And then the promise with the value of slow, well, that's not going to run until after 500 milliseconds. So that's going to resolve after promise 2 here. And the Promise.any method is going to return the first successfully fulfilled promise. And as you will see, if I change this to be 800 milliseconds for promise 2, and then I run this, you're going to see that I get slow, console logged out, because now promise 3 is going to fulfill after 500 milliseconds with the value of slow, but it's going to short circuit and return the value of that promise. And we aren't actually going to handle promise 2 because it's going to resolve after. Okay, so the Promise.any method within JavaScript, it takes an array of promises and it will return the first successfully fulfilled promise, but it will ignore any rejected promises. And once it returns the first successfully fulfilled promise, it will kind of short circuit and it won't continue to wait for any other promises to resolve. And since it returns a promise, you can handle it with the .then method. Now, how is this different than the Promise.all, Promise.allSettled, and Promise.race methods? Well, Promise.all, this is going to actually return an array of fulfilled values. But in Promise.any, we only get one fulfilled value. So Promise.all, it's not going to short circuit these values, and it's going to return all the fulfilled values. So let's take a look at how this works. And let me actually resolve promise 1 here, because that's going to make sure that this works properly. And if I change this to Promise.all, what you're going to see is that we actually get an array of all of the fulfilled values. So it doesn't short circuit and just return one value. Now, Promise.all.settled, it's very similar to Promise.all. It returns an array, but it's going to return an array of all of the settled promises, regardless of whether they reject or they fulfill. So in my example here, if I reject this promise and I run my code, you're going to see that I console logged rejected. I no longer get an array of these fulfilled promises here because my promise array had a rejected promise in it. So that's going to reject all of them, and it's just going to go into my .catch method. So with Promise.all, if you have a rejection, it doesn't return the fulfilled values. But if I use Promise.all.settled here, it will return an array of all the fulfilled values. So here you can see that I get an array of objects. So that's another kind of difference there. It gives you an array of objects. And then I get the status, whether it is rejected or fulfilled. And then I either get, if it's rejected, I will get a reason for it. And in this case, My reason doesn't make sense because I just reject it with a value of 0, but you might imagine that this would be a string describing the reason of some error here. And then if I run this again, you're going to see I do indeed get a reason as some error, but I still get the fulfilled values within my return value here. So Promise.all.Settled, it's going to return an array of objects kind of describing all of the values, even if a value rejects. Now, Promise.race here, which I think is very similar to Promise.any, it's going to return the first value, whether it is a rejected value or a fulfilled value. But Promise.any, it's only going to return the first value that fulfills successfully. So if we look at this, we see that I get rejected because that is my first promise that kind of fulfills here. And I can change this to resolve, and we're still going to see the same output because I'm not waiting at all to resolve this promise. So that's going to be the first one that returns. But if I comment this out and I delete this, you're going to see that the first promise that resolves here is going to be my one with 500 milliseconds compared to one with 800. So if I run this, it's going to return slow because that is my first promise that fulfills here. And the difference between Promise.race and Promise.any is that Promise.race is going to return the first promise that either resolves or rejects, to where Promise.any, it's only going to return the first promise that resolves successfully. Okay, so hopefully that gives you a good idea of how Promise.any works and the differences between Promise.all, all-settled, and race. Stay tuned for future videos where I hit a little bit more in depth on Promise.all, all-settled, and Promise.race, as well as more asynchronous things in JavaScript. So thanks for tuning in, and I'll see you in that next one. In today's video, you're going to learn everything you need to know regarding the Promise.race method within JavaScript. We're first going to go over a conceptual explanation of how this method works. Then we're going to cover some examples to kind of make things a little bit more clear. And then we're going to discuss some differences between Promise.race and Promise.any, Promise.all, and Promise.all.Settled, the other promise methods that are useful within JavaScript. So first things first, what is Promise.race? Well, Promise.race is a method on the overall promise object. So you get a promise object within JavaScript that you can use for free. And Promise.race is a method that you can access on this object. And Promise.race will take one argument. And this will be an array or an iterable containing promises. So you pass an array of promises to the Promise.race method. And what this method will do is it will resolve, or it will return, a promise. And more specifically, it will return the first promise that either fulfills or rejects within your input array of promises. So you pass it this input array of promises, and the very first promise to either fulfill or reject, hence the name race, there's a race for the first promise to either fulfill or reject, and whichever promise either fulfills or rejects first, the Promise.race method will return a promise representing whatever promise either fulfilled or rejected first. Okay, so let's dive into an example here to make things a bit more clear. So in my example here on line 16, I have a promise that I create, and it's called Promise1. And I assign the constant Promise1 to a new promise. So I use the new keyword, and I invoke the overall promise constructor function, and I effectively create a promise that is going to reject after 100 milliseconds. So this code here is going to create a promise that rejects after 100 milliseconds with the value of quick. And then on line 18, I do something very similar in which I assign a constant Promise2 to a new promise. And this is effectively going to create a promise that resolves after 500 milliseconds with a value of slow. So knowing what you know about the Promise.race method, what do you think is going to happen when I take my promises array here and I pass it into Promise.race? Well, it's going to return a promise representing the first promise here that either fulfills or rejects. And in this case, the first promise that either fulfills or rejects is going to be Promise1 with the value of quick. So since Promise.race returns a promise, you can handle that promise with the .then method, just like what I do here. And then here I just console log the value. And similarly, since it returns a promise, I can also handle it with the .catch method. So if a promise resolves, we're going to enter this .then block. And if a promise rejects, we're going to handle this .catch block. So in this example here, since promise 1 is set to reject after 100 milliseconds, which is going to be before promise 2 here, set to resolve after 500 milliseconds, I would expect this Promise.race method to handle its catch block here and console log the value of quick, because this promise 1, it will reject before promise 2 has the time to resolve. So if I run my code here, you're going to see that I console log quick because I'm console logging the rejected promise here because it rejects after 100 milliseconds. Now, if I switch this to 700 milliseconds, well, now promise 1 is going to reject after promise 2 resolves here. So if I run this code, you see that I console log slow because now promise 2 is actually going to resolve ahead of promise 1. So Promise.race is going to return a promise representing promise 2 here because it's going to resolve first. So the Promise.race method within JavaScript, it takes an iterable or an array of promises, and then it is going to return a promise. And this promise that is returned by Promise.race is going to represent the very first promise that either resolves or rejects within your passed in promise array. And then it's going to ignore all of our other promises within that array. And there's just that race for the first promise to come back. It is going to return that within this method. Now, how is this different from the other promise methods? Well, when looking at the difference between Promise.race and Promise.any, it's actually very similar in which Promise.any, it's going to return the first promise that resolves. However, Promise.any actually ignores rejected promises. So Promise.any works the same way as Promise.race, except it only works for resolved promises. So in this example here, if I have this promise to reject after 100 milliseconds, well, Promise.race, we saw that it returns promise 1 here. But if I change this to Promise.any, we're actually going to see that it ignores the rejected promise and it's still going to return the first promise that resolves. Now, the difference between Promise.race and Promise.all.settled is Promise.all.settled is going to wait for all of your promises within your passed in array to fulfill or reject, and then it's going to return an array of values representing those fulfilled or rejected promises. So Promise.all.settled, it'll wait for all the promises to kind of all fulfill or reject. And then the difference between Promise.race and Promise.all is that Promise.all, it will wait for all fulfilled promises to kind of settle, and then it will return an array representing the value of all the promises that resolve. However, with Promise.all, if any promise rejects, then it's just going to reject immediately, and it's not going to wait for all other promises to resolve. Okay, so that is Promise.race within JavaScript and the differences between some of the other promise methods. So stay tuned for more videos on asynchronous JavaScript and other tutorials helping you within your kind of web development learning. So thanks for tuning in, and I'll catch you in that next one. In today's video, we're going to cover the Promise.all.settled method within JavaScript. First, we're going to talk about a conceptual explanation of how this method works. Then we're going to get into some examples and use cases, and then we're going to end with how it's different than some of the other promise methods. So first things first, what is the Promise.all.settled method? Well, it is a method on the overall promise object that you get for free within JavaScript. And I will show you examples of how this works in a second, but it is a method that exists on that object. And what it's going to do is it's going to take an array of promises or an iterable of promises, and it's going to return a promise that will fulfill when every promise from your input array has either fulfilled or rejected. And then for every promise that either fulfills or rejects, it is going to represent that with an object. And each object is going to have a status string telling you whether the promise was fulfilled or rejected. So that status is going to be fulfilled or rejected. And then if the promise was fulfilled, then your promise object is also going to have a value property. And that value is going to point to whatever value that promise fulfilled with. But if your promise was rejected, then it's going to have a status of rejected. And then instead of a value property, it's going to have a reason property. And that reason property is going to point to whatever that promise rejects with. So a reason for why that promise rejects. All right, so if that doesn't make a ton of sense right now, let me show you an example of this. So in this example here, I'm going to create two separate promises. Promise 1 here on line 22 and promise 2 here on line 24. And I'm basically just going to use the promise constructor within JavaScript to create these promises. And my first promise is going to be a promise that rejects after 100 milliseconds with the value of quick. And then my second promise, promise 2 here, it's going to be a promise that resolves after 500 milliseconds with the value of slow. And then I place these promises into a promise array. And then for the Promise.allSettled method here, I'm going to pass it an array of promises. So I'm passing it my array of promises here. And then the Promise.allSettled method, it's going to return a promise. So I can handle that return value with either the .then, the .catch, or the .finally methods. And those methods are going to run once my allSettled methods promise resolves. And my allSettled methods promise is going to resolve when all of my input array promises either fulfill or reject. And it's going to return an array here within my resolved promise in which each item of that array is going to be an object representing each promise of my passed in input. And like I said, those objects are going to have a status property that is either fulfilled or rejected. And then if a promise was fulfilled, it's going to have a value property pointing to the value that promise was fulfilled with. And then if it rejects, it's going to have a reason property pointing to the reason why that promise rejects. So if I run my code here, you're going to see that I get an array here of objects in which each object represents one of my passed in promises. And my first promise, it's going to have a status of rejected because I reject that promise here. And it's going to have a reason because it rejects. It's going to have a reason property. And that's going to be with a value of quick here. And then for my second promise here, I set that promise to resolve. So it's going to have the status of fulfilled. And then it resolves with a value of slow. So it's going to have the value pointing to slow. So the Promise.all method, it's going to return a promise. And this promise is going to contain a value, which is an array. This array that you see here, and each item of this array is going to be an object that represents one of your passed in promises within your promise array that you pass to the allSettled method. And then each object is for sure going to have a status property, and it's either going to be rejected or fulfilled. And if it was rejected, then it's also going to have a reason property for the reason why it rejected. But if it fulfills, then it's going to have a value property pointing to the value that it fulfills with. Okay, so this gives you a way to handle multiple promises, either rejecting or fulfilling, and handling either case, whether they reject or fulfill. But how is this method different than some of the other promise methods? Well, for the Promise.any method, it's just going to return the first resolved promise. So if I change this to Promise.any and I run this code, you're going to see that it's only going to return the first promise that fulfills. So since I only have one promise that fulfills and it fulfills with a value of slow, Promise.any is just going to return the first value that fulfills. So the Promise.any method, it's not going to wait for all of your methods to fulfill or reject like Promise.allSettled. And that's kind of the same thing with Promise.race. Promise.race, it's not going to wait for every promise to resolve or reject like the Promise.allSettled method will. It's going to return the first either fulfilled or rejected value. So if we run this with Promise.race, you see that we're going to get quick because my promise 1, that's going to reject after 100 milliseconds, which is going to be before promise 2 that resolves after 500 milliseconds. So since Promise.race, it doesn't care whether something rejects or fulfills, it's just going to return the first resolved or rejected promise. But Promise.allSettled, it's going to wait for all those promises and return an array of objects representing each promise. And Promise.any, it's going to ignore rejected promises, just returning the first fulfilled one. Now Promise.all, it's different than Promise.allSettled because it returns an array of all of your fulfilled promises. But if any promise rejects within the Promise.all method, then it will immediately reject your returned promise from Promise.all. It's not going to wait for all promises that either reject or resolve. It's only going to wait for resolved promises, and then if something rejects, it's just going to reject everything right away, short circuit it, and not wait for any other promises. So if I change this to Promise.all here, you're going to see that it's just going to reject here with the value of quick. And it's not going to wait for all of my promises. But if I change this to resolve, now it's going to return an array of all of the values within my resolved promises here, because I resolve this and it waits for both resolved promises since there's no rejection. Now, you might be thinking that Promise.all and Promise.allSettled are very similar, and they are. The main difference is when a promise gets rejected, Promise.all is going to immediately reject everything, but allSettled, it doesn't care whether it resolves or rejects. It's just going to return an array of objects representing all those promises, whether they resolve or reject. So the Promise.allSettled method, you might use this method in a case in which you want to have multiple asynchronous operations happen at the same time, and you want them to happen in parallel, but they are independent of one another. Meaning, if one of your promises rejects, you don't want to reject all other promises. You're okay with just handling those independently. That's where you'd use allSettled over Promise.all. But if your promises were all dependent on each other, and if one rejected, you want them all to reject, then you would use Promise.all. Okay, so hopefully this gives you a good idea on how the allSettled method works within JavaScript. I have other videos covering all the other methods in a little bit more depth, as well as some different use cases and examples of when these methods are useful. So thanks for tuning into this, and I will see you in that next one. In today's video, you're going to learn everything you need to know regarding Promise.all in JavaScript. First, we're going to cover a conceptual explanation of how Promise.all works. Then we're going to get into a couple of different examples of where this is potentially very useful, especially like when you're using it for a fetch request. And then also we will cover some of the main differences between Promise.all and some of the other promise methods like Promise.any, Promise.race, so on and so forth. So first off, the conceptual explanation. Well, Promise.all is a method that you can use on the overall promise object that you get for free within JavaScript. And what this is going to do is it's going to take an array of promises and it's going to return a single promise. And this single promise is going to fulfill when all of the promises within your input array have fulfilled as well. So you pass it an array of promises, and once all of those promises fulfill, Promise.all will return a promise that will contain an array of all of the values of the promises that fulfill. Now, if one of the promises within the input array rejects, then Promise.all will reject immediately if any of those input promises reject. Okay, so Promise.all takes an array of promises that will fulfill with a single promise that will have an array of values representing all of the values of the input promises that you passed in. But if any of those input promises reject, then Promise.all will reject as well, and it will do so immediately without waiting for any other promises to fulfill. So let's look at an example here. So in this code right here, I have created a few different promises. Here on line 23, I create a promise by just calling my Promise.resolve method and passing in some error. So it's going to resolve with the string some error. And in just a second, I'm going to change this to reject, which will make this string that I pass in a little bit more sensible. And then on line 24 here, I create a new promise with the promise constructor, and then I have this promise to resolve, and we're going to change this to just 100 milliseconds here. So promise 2, it's going to resolve a promise after 100 milliseconds with the value of quick. And then promise 3 on line 26 here, it's going to resolve a promise after 500 milliseconds with the value of slow. And then now that I have created these three different promises, I'm going to put them all within an array called promises here on line 29. And then I'm going to use the Promise.all method. So I'm going to access the all method on the overall promise object that you get for free within JavaScript. I'm going to pass in my array of promises. And then once all of my promises fulfill, that is going to return a promise. And since that returns a promise, I can use the .then method to handle that returned promise. So I'm going to use the .then method. It's going to automatically pass in the values of my fulfilled input promises here. And that is going to be an array of values. And then here, I'm just going to console.log those values out. And then if any error occurs, I'm just going to console out rejected. So if I run this code here, you're going to see that I get an array of some error, quick, and slow. I get an array of all of my resolved promises here. So the Promise.all method takes an array of promises here, and it will return one single promise. And then you can handle that promise using the .then method. You could also potentially use Async Await here. And then what it's going to do is it's automatically going to pass the values of your input promises. It's going to pass those fulfilled values as an array to your .then method, and then you can handle them in some way here. Now, if I have a promise that rejects here, it is going to reject this immediately, and it's not going to wait for any other promises. So you can see that now that I have a single rejected promise here within my promises array, it enters the .catch method because it rejects immediately, and it's not going to fulfill with any of the other values here, even if those promises resolve. Now, another really good use case here for this Promise.all method is when using fetch requests. And why is this a good use case here? Well, if you are going to make multiple fetch requests in your program kind of at the same time, and let's say that you need to handle the values of the requests at the same time as well. Well, one way you might think about doing this is using your kind of fetch method here. And then, you could, onto this fetch method, you could add a .then to this fetch method, and then you could handle the value here. And then once you have that value, you could do another fetch with inside of here. But the main problem with doing this is that you're going to do this entire fetch method, and then you're going to wait for that to come back, and then you're going to do this fetch method, and you're just going to kind of take a lot of time running these kind of sequentially throughout your program, because you'll have to wait for the first one to come back, and then you'll do the second one. You'll have to wait for that to come back. And then let's say you had a third one, you'd have to wait for that to come back. And that can potentially slow down your programs to a significant degree if you have to constantly do this waterfall of waiting for one fetch method to come back before you perform the next one. So a better idea would probably be to just run these fetch methods in parallel here. Now, how can you do that? Well, this is where you can use the Promise.all method. So in this example here, I have a function called getStuff. It's an async function. And within this async function here, what I'm going to do here is I'm going to use the fetch method and fetch this API here. So this is just going to return some dummy data from this API. And fetch automatically returns a promise. So I assign that promise to the constant promise1. And then here on line 43, I make another fetch request and I assign that to promise2. So both these fetch methods return a promise into these constants here. Now, as you can see here, I'm not doing something like this. I'm not awaiting these fetch methods right away. Because if I awaited these fetch methods right away, that would run these sequentially, meaning we would await for this fetch method to resolve, and then we would continue our function here, and we would await this one, and then we would kind of continue down the rest of our function. And that would run these sequentially. But here, I'm just allowing my fetch methods to return a promise right away. So we're going to run this code, and then we're going to run this code immediately. We're not going to wait for this one to return. And then on line 43, I'm going to use the Promise.all method, and I'm going to pass in an array of my promise1 and my promise2. And like I said earlier, this Promise.all method, it's going to return a promise once both of these fulfill here. And if any of them reject, then it would immediately reject. But this is where I use my await keyword. So I'm going to await for both of these to resolve, and I'm going to wait for my Promise.all to return my fulfilled data here. And if I call this function here, you're going to see that I do indeed get an array of my data here, in which each to-do has a title, a user ID, and completed, and so on and so forth. So this allows me to run my fetch requests here in parallel, potentially dramatically increasing the performance of my application rather than needing to perform this fetch request first and waiting this to come back and then moving on to this one and not allowing this one to run until this one's completely fulfilled. That's potentially going to cause some performance issues and just a slower program overall compared to performing both of these fetch requests effectively at the same time and then handling those values once they both fulfill. All right, so that is a very good use case for this Promise.all method that can have significant impacts in your programs. Now, how is Promise.all different than the method Promise.any? Well, Promise.any, it's just going to return the first resolved promise. It's not going to wait for all of your promises to complete, because Promise.all, it's going to wait until all of your fulfilled promises complete, and then it's going to return an array of those values to where Promise.any, the very first time a promise fulfills, it's going to return that. And if any promises reject, Promise.any actually ignores it, and it just waits to return the first fulfilled promise. And then with the all-settled method, it does wait for all of your promises to fulfill. However, it handles rejections differently, in which all settled, it's going to wait for all of your promises to fulfill or reject. And it's going to return an array of objects representing these promises. And it's going to contain whether the promise fulfilled or rejected. And then it's going to contain the value. And it might even contain a reason why your promise fulfilled or rejected. To where Promise.all, if anything rejects, it's just going to reject immediately and not wait for your other promises. And then the difference between Promise.all and Promise.race is that Promise.race is going to return the first fulfilled or rejected promise. It's not going to wait for all of your promises to fulfill. It's just going to return the first rejected or fulfilled promise, which that's also the difference between Promise.race and Promise.any, where Promise.any, it's going to ignore any rejected promises, to where Promise.race, it's going to actually return that rejected promise or any promise, the first one that resolves or rejects. So stay tuned for future videos where I cover all settled and race in a little bit more depth. I already have a more in-depth video on Promise.any, and I recommend checking that out as well. So thanks for tuning into this video, and I'll see you in that next one. In today's video, you're going to learn everything you need to know about the event loop in JavaScript. I think understanding this topic and understanding the JavaScript runtime is going to allow you to be a much better JavaScript developer. So JavaScript is a synchronous, single-threaded language, which means that by default, it goes through your code and executes it line by line, one thing at a time, because it's single-threaded, and it just synchronously goes one line after the other, executing your code throughout your program. Now, what happens when you have some task to perform in JavaScript that takes a long time? Well, by default, you might think that, okay, well, JavaScript is single-threaded. It only can do one thing at a time. So when it has to perform that task that takes a long time, it's probably just going to kind of block the program until that long task is finished. And then JavaScript can continue synchronously going down your code line by line. However, if this was the case and every time you did something that took a long time, so a good example of this could be like a network request that might take a second or two to complete. Well, while that's occurring, if that blocked your JavaScript thread, that would also block all of the interactivity on your web page, which would probably create really poor apps within JavaScript because the user would always have a blocked application and they wouldn't be able to do anything. So that would create really unperformant, poor applications. So the way that JavaScript solves this is allowing for asynchronous behavior, meaning once you hit a task that takes a longer amount of time to do, you can actually just put that task into a task queue. And then once that task is completed, you can bring that data back into JavaScript and continue running through your program. And you never block that single thread. So you hit something that takes a long time to do, You push that off to some other queue. You let the JavaScript thread continue running its code, allowing your web page to have interactivity. And then at some later point, the data from that task is going to come back in to your program. Okay, so that's kind of an overview of the problem that we're solving here, allowing for this asynchronous behavior. But let's first understand a little bit more on JavaScript execution and how it by default executes its code. So there are kind of two parts to JavaScript execution, or how JavaScript executes your code. One is it's going to have a single thread that goes through your line by line to execute your code. And then also it's going to save stuff to memory. So here, if we look at this example, the way that this is going to work is JavaScript's going to hit line 21. It's going to be like, okay, they're trying to define a constant called person and assign that to the value of Ryan. So JavaScript's going to hit this line and it's just going to store this to global memory here. And then it's going to hit line 23 here. And it's going to be like, all right, they're declaring a function named greeting, and it's going to have a parameter of name to greet. So it's just going to store this to memory here. Now, importantly, it's not going to enter the body of this function until this function is actually called. But it is going to save this function definition here to memory. And then I'm going to come to line 29 here. And I'm going to say, all right, well, we have a constant, hi Ryan, and we're going to assign that to the return value of calling this greeting function and passing in my person argument here. So then once I call this function, JavaScript's going to go inside the body of this function. It's going to assign my person variable here to this name to greet parameter, and then it's going to return hello Ryan, or hello whatever this parameter is. And then once JavaScript has completely finished executing this code here, and this call to the greeting function has completed and resolved with some value, then JavaScript will head to this line 30. But it won't do that until it's completely done running this greeting function, because it's synchronously going to go through your code line by line here. And then it's going to do the same thing here, in which we call greeting with the value of Joe. So if I run this code here, you're going to see that I get kind of what you would expect. I get hello Ryan and hello Joe. Now, one important thing to remember is that in JavaScript, it has something called a call stack. So when I'm running this greeting function, we're actually going to push this function onto the call stack. And this function is going to remain on the call stack until it has completed executing. So if we back up a little bit, when I hit line 29 here and I call greeting, it's going to push this greeting function onto the call stack. And the call stack allows JavaScript to kind of know where you're at within your program. It allows you to know what function is currently running in your program. And you can kind of think of your programs here always kind of running within some global function. So when I'm running or executing this global code here outside of my greeting function, you can think of it as JavaScript has the global function on the call stack to run that function. And then once I hit this greeting line, it's going to push this greeting function onto the call stack. It's going to create its own kind of execution context to execute this greeting function. And then once this function resolves with a value, it's going to pop it off the call stack and move to the next line. And then we're going to hit this next line here. It's going to push this greeting function onto the call stack, execute all of its code, and then continue running line by line throughout your code. So JavaScript will use this call stack to push functions onto, execute those functions, and then pop those functions off, and then continue running whatever function that was next in the call stack. So say I had another function within this greeting component here, or I called out to another function. What JavaScript would do is, okay, well, we would call greeting here. This would put greeting onto the call stack. And then if I called another function here, it's going to place that on the call stack, and it's not going to continue running this greeting function until this some function has completely finished executing. So our call stack, the way that this would look is, okay, well, we would have our main function at the bottom of the call stack. Then we would push the greeting function onto the call stack here when we call it. And then since this greeting function, it calls another function called some function, we're going to push some function onto the top of the call stack. And then once some function has completely finished executing, we will pop that off of the call stack, and then we will continue running the greeting function. And then once that's completely finished, we're going to pop that off the call stack, and then we're going to continue running our main function. So this call stack allows JavaScript to kind of know where we're at in the program, and it's a way to kind of predictably order what functions are executing within your program here. So the default behavior of JavaScript is going to be synchronously going through your code line by line, executing it. And then when a function is executed or called, it's going to push that function onto the call stack, complete the running of that function, pop it off of the call stack, and continue running whatever function was kind of underneath it within the call stack. Now, like I said in my intro, this is a fine default behavior. But when we need to do some task that takes a long amount of time to do, like a network request, or if we have some set timeout or something like that, well, we don't want to block our main thread of execution until that is completed, because it's going to prevent a good user experience and it's going to make our programs much slower. So JavaScript allows for asynchronous behavior in which we can actually just use something called a task queue. We can push those tasks to this queue, and then at some later date, that data is going to come back into our programs. But how does that data come back into our programs? Well, this is where the event loop comes in. And what the event loop is going to do is we're going to be running our synchronous code, but the event loop is constantly going to be checking. Okay, it's going to be checking our main call stack in our JavaScript program. It's going to see like what function is running and what functions we have on our call stack. And it's also going to be checking this task queue. So this, you can think of this, conceptual loop just going around, checking our main call stack, checking our task queue, checking our main call stack, checking our task queue. And what it's kind of looking for is, okay, it's going to constantly be asking, is our main call stack completely empty? Meaning, are we finished running all of our synchronous code within our program? There's no functions left on our call stack. If yes, then it's going to check our task queue. And it's going to ask, okay, is there data from our task queue? Did some task complete? And is that task ready to kind of come back within our JavaScript program to execute and to finish the running of that task? If yes, it's going to bring that task back into JavaScript, push it onto the call stack, and then JavaScript will execute that. Okay, so this event loop is going to constantly be checking, is all of our synchronous code within our program completely finished, and is our kind of main call stack empty within our synchronous JavaScript program? If yes, then it can bring things from the task queue into our program. If not, it will not touch the task queue. All right. So let me show you an example of this. I define a constant called person here on line 37. I have my same greeting function defined on line 39. But then what we do here is on line 45, I actually set a timeout in which all I'm going to do within the set timeout function is I'm going to console log calling the greeting function with my person. So I'm just going to console log hello name to greet. But I'm going to call this function after 500 milliseconds. And set timeout, it is actually an asynchronous function within the web browser. And since it's an asynchronous function, this set timeout function, it's actually going to be pushed to the task queue. And within JavaScript, some functions are just inherently asynchronous. So this would be the set timeout function. This would be the fetch function to make network requests. This would be the set interval function. All of these are web browser functions that are asynchronous, and their code is going to be pushed to this task queue. So JavaScript can complete it at some later point. So this is an asynchronous web browser function, meaning when I hit line 45 here, what JavaScript is going to do is it's like, okay, well, we want to run this passed in inline function here after 500 milliseconds. So it's going to push this function to the task queue, and then it's going to keep going through our code line by line. And then we're going to hit this line 48 here. We're going to call the function greeting with the value of Joe, and then I'm going to console log that out. And then in my program, I have no other active code here. So the way that this is going to work is once we push this set timeout function to the task queue, JavaScript is not going to execute this function until two things happen. One, all of our synchronous code has completed running. That is priority one. The event loop, it's not even going to look at the task queue until all of our synchronous code is complete. But then once it is, Then we're going to make sure that this timer has completed. So 500 milliseconds, once that is up, and once all of our synchronous code is complete, then it's going to run this function. So if I run this code here, you can imagine that I do get hello Joe, and then I get hello Ryan. Because I hit line 45 here, I push this function to the task queue, and then the event loop, it's not going to push this data from the task queue back into JavaScript until all synchronous code is complete. So I'm going to hit line 47, then I'm going to hit line 48. I'm going to call my greeting function again. Then I'm going to console log Joe. And then it's like, okay, well, our main call stack is now empty. I have no other active code in my program here. Do I have anything in my task queue? Yes. Has it been 500 milliseconds yet? Well, it's going to wait until it has been 500 milliseconds. And then this greeting function will then be executed, and I'll console log the return value of my greeting function, which is why you see hello Joe and hello Ryan. Now, the main rule of the event loop is it is not going to use any of your functions in your task queue until all of your synchronous code has completed and your main call stack is empty. And this is likely a good thing because it gives you certainty of when this asynchronous code is going to execute within your program. Like, what if the event loop just randomly started pulling functions in from your task queue throughout your program? That would be chaos, right? So it does this to give predictability of, okay, any asynchronous function here out in my task queue, it is not going to be pulled into JavaScript from the event loop until all synchronous code has completed. And then, like I said earlier, some asynchronous web browser functions that are just asynchronous by default, they aren't necessarily things that you have to like create or construct your own promises for and stuff like that, are fetch, set timeout, and set interval. Now, one thing to note is that there are indeed multiple queues. There is a task queue and a micro task queue within JavaScript. And I'm going to hand wave over that a little bit and not get into too much detail here, but just know that let's say you have multiple asynchronous tasks kind of queued up, ready to go. Sometimes JavaScript will prioritize some tasks over others. And if you see in your program that one asynchronous task is being performed over another one, and it seems kind of counterintuitive, it might come down to using multiple queues here and the micro task and task queue. But I will create videos on this in more depth in the future. All right. Now, one last thing I want to touch on here that I think is super important to understand is, what if I change this value to 0 milliseconds? Super common interview question here to kind of judge your understanding of the task queue and the event loop. Well, go back to the main rule of the event loop. The event loop is not going to pull in any of your asynchronous tasks until all of your synchronous code has completed and your main call stack is empty. And since this is the case, and since this is an asynchronous task here, well, JavaScript's going to hit line 45. It's going to push this task to the task queue, no matter what. It is asynchronous function. It's going to be pushed to the task queue regardless of the amount of time right here. So since that is true, how do you think that this is going to be run here? Often, if people don't understand that set timeout is asynchronous, it's going to be pushed to the task queue, and they don't understand the rules of the event loop, they're not going to know that JavaScript, it is not going to run this passed in function here until all synchronous code has completed and the main call stack is empty. So the way that this is actually going to work is the same way it worked before. We're going to console log hi Joe right here. We're going to finish all synchronous code. And then the event loop is going to say, okay, our main call stack is empty. Is anything in our task queue? Yes, we do have this function in our task queue. And it doesn't have any time on it. So we're not going to wait at all. We're just going to execute it right away. So if I run this function here, you're going to see I get the same result here, because even in a set timeout and you put 0 milliseconds, JavaScript's still going to push that to the task queue, and the event loop's not going to pull it back into JavaScript until all synchronous code has completed and the main call stack is empty. So the main rule, or the main thing to remember with the event loop, is that it is not going to pull in asynchronous tasks from the task queue within JavaScript until all of your synchronous code is completed and your main call stack is empty. It doesn't matter if there's a super long for loop or something like that. It's not just going to randomly pull in these asynchronous tasks. It is going to stick to this main criteria right here. And I think understanding this really allows you to understand your JavaScript programs much better. So I hope this helped you understand how the event loop works and how asynchronous code works a little bit better, and also how JavaScript execution works with being single-threaded and going through your code line by line. So thanks for tuning into this, and I'll see you in that next one. In today's video, you're going to learn everything you need to know regarding async await within JavaScript. I'm first going to give you an overview of what async await is and what these keywords are within JavaScript. And then I'm going to go over several examples here of how it works and how you can use it in your programs. All right. So first things first here, what is async await? An async function is a function declared with the async keyword. So async is a keyword within JavaScript that you can put before functions, and that tells JavaScript, hey, this is an asynchronous function. And then the await keyword is a keyword that can be used within an asynchronous function, and it needs to be used within an asynchronous function, but it allows you to pause your async function until some promise either resolves or rejects. So it's like, hey, let's just hold on. Let's stop this function for now. Let's go do some other stuff within JavaScript. And then once this promise resolves or rejects, then we will come back to this kind of line of code within this function, and then it will continue running that function once that promise is like all settled and all completed. And these async and await keywords, as you might have guessed, allow you to perform asynchronous JavaScript, and async await can kind of give you a syntax that just looks a bit cleaner and can be a little bit more easy to reason about. And it is probably the most modern way to handle asynchronous programming within JavaScript. So moving in to some examples of how these work. So to create an asynchronous function here, what you need to do is use the async keyword, and you are going to place that keyword right in front of your function declaration. So as you can see here, I use the keyword async, and then following that keyword, I create a normal function declaration. So this is an asynchronous function called getData. And then I could have some logic within the body of my function here. Now, for an asynchronous function, they can take various arguments, just like a normal function. There's not really anything special when it comes to passing arguments to an asynchronous function. However, unlike normal functions, they will always return a promise. So asynchronous functions, they always return a promise. So you can kind of think of asynchronous functions as always wrapping the return value of your async function within a promise. So if we look at these two examples here, I have my async function called async function, and then I just have a regular function called function. And you can kind of think of these two as equivalent. In my async function, I just return the value of 1. But in my regular function, I return promise.resolve, and I pass in 1 to return a promise here that is resolved with a value of 1. So these are effectively the same thing. Now, there are some like subtle nuances that these aren't actually the same thing, but it is an appropriate mental model to think of an async function just returning 1. Well, that is very similar to a regular function returning promise.resolve and passing 1 into it. So if I console log the return values of both of these functions, you're going to see that I get a promise with a value of 1 within both of these, because an async function, it's going to wrap whatever return value you have within a promise, similar to if you just had a regular function and you called promise.resolve and you wrapped that value within a promise. Now, you can handle this return value with a .then function, and you could get the value with a .then function just like you would with working with promises in general. So if I get rid of my console.log here and I attach a .then and I get the value of this function, and then I just console log the value here, you're going to see that in my async function, I'm going to be able to access the value of it by using this .then function, because this is going to return a promise here, and then I'm going to wait for that promise to resolve with my .then function. I'm going to get the value of my promise, and I'm just going to console log that out. So if you want to use the value of an async function, like I do here, you can just attach a .then, .catch, just like you would handle kind of regular regular promises there. Okay, and then if you're inside an async function, you could also await the resolution of a promise there. All right, so an async function within JavaScript, it is automatically going to return a promise, and it's going to wrap whatever return value you have within a promise. Now, as I mentioned in my overview, within an async function, we can use the await keyword. Now, the await keyword, it needs to be within an async function. There are some nuances to this, but for the most part, excluding some edge cases, await keyword needs to be used within an overall async function. And async functions, they can have 0 or more await keywords. They don't necessarily need to have an await keyword, just like in my examples I showed, nor is there a limit to the await keywords they have. And like I said in my overview, the await keyword, it will wait for some promise to resolve before it continues running a function. So in my async function here called async, I define a constant called data, and then I assign that to the return value of using the await keyword, and then I await a new promise here that resolves after 3,000 milliseconds or 3 seconds. So what JavaScript's going to do here is it's going to enter this async function, and then it's going to hit this line of code here. It's going to see this await keyword, which is telling JavaScript that I want to wait for some promise to become settled, to either fulfill or reject. And once it sees this await keyword, it's going to be like, okay, well, this promise, it's not resolved yet. It's going to take 3,000 milliseconds. So it's then going to exit the running of this async function. It's going to continue running all synchronous code throughout my JavaScript program. And then once all of my synchronous code is complete and this promise resolves or rejects here, it's going to come right back to this line of code here and continue running this async function. So once this promise resolves after 3,000 milliseconds, then data here is going to be assigned to whatever I resolve or reject my promise with. And then here I'm just going to console log my data. So if I run my async function here, what you should see is that I'm going to run it. There's going to be a slight pause of 3,000 milliseconds to where it runs the rest of my code here, which I don't call any functions in the rest of my code, so nothing else is going to happen. And then after 3,000 milliseconds, it's going to come back to this line of code and complete the running of this function. So if we look at my example, I ran my function and we see how it's waiting there for about 3 seconds, and then it console logs out 1. Because it hits this line of code, it exits this line of code. And just to show you that I'm not lying to you, let me just console log some synchronous code here. And I'm going to just console log sync for synchronous. So what's going to occur this time is we're going to hit this line of code. JavaScript's going to exit my function here. It's going to run all other synchronous code throughout my program. And then once this promise resolves or rejects, it's going to come back to this line of code, but only after it's run all synchronous code in the rest of my file here. So if I run this here, I would expect to console log sync here before I console log the value of 1. Because once it hits this line of code, it's going to exit this function. It's going to run this line of code because this is synchronous code. It's going to run all synchronous code. And then once my kind of synchronous code call stack is cleared, it will come back to the running of this function once this promise is resolved or rejected, and then it will console log out 1. So if I run this again here, we see that I console log out sync, and then after 3 seconds, I console log 1. Now, what happens here if I don't await this promise? I don't wait for this promise to resolve or reject. So let me get rid of this. And I'm going to get rid of this sync statement here as well, just to make things a little bit more clear. So if I run this now, what you should see here is me getting a pending promise because I'm not waiting for this promise to resolve or reject. And that's what I get. I get a pending promise here because I'm not waiting for this promise here. But if I do wait, then I'm waiting for that return value, and I will get the value of 1 after 3,000 milliseconds. Okay. Now within an async function, there's a bit of a different way compared to just using regular promises that you can handle promise rejections and different things like that. And the way that that is done is using a try, catch block, and you can also use a finally block. So here within my async function called handle, I basically have the very same example here in which I define a constant called data, and I assign it to the return value of a new promise that's going to resolve here after 3 seconds. And then I console log the data. But what I do here is I wrap that within a try block, which is basically telling JavaScript that, okay, I want you to try to run this asynchronous code here, but if there's some sort of error, like a network failure or something like that, if some error occurs while I'm trying to run this code within my try block, then it's going to enter this catch block here. And whatever error is thrown, that is going to be passed in to your catch statement here. So here I'm kind of capturing my catch error. But if no error occurs, then I'm just going to finish running my entire try block here. And then in either case, if I want to run some code in either case, then I'm going to add that to my finally block. So you can have these try, catch, and finally blocks here. So your try block, that is going to run to completion if no errors occur. And if no errors occur, you're not going to run your catch block. But if an error is thrown, then you are immediately going to be thrown into your catch block here. And in either case, you're going to run your finally block. And finally blocks might be useful if, like, say you have some state that you want to set to loading when you kick off a network request, and you don't really care. Like, regardless of whether your promise fulfills or rejects, you want to set your loading state to false. That would be a good use case of using a finally block, because that's going to run whether your promise resolves or rejects. So if I run this code here, right now, since I just resolve my promise, what you're going to see is that I'm just going to console log out my data here, which is going to be the value of 1. And then I am going to console log about time, because I am going to enter this finally block regardless in my program. So here you see that I'm first going to log out the value of 1 because I'm going to wait for my promise to resolve here. And then once that does resolve, I'm going to continue the running of this function, and I'm going to console log out 1. And then here, my finally block is going to run regardless. But if I change this to a reject here, what you're going to see is that this promise is actually going to reject. So I'm never going to hit this line of code here. It's just going to go straight into my catch block, and it's going to pass in whatever value I reject my promise with, which is the value of 1. And then I'm going to console log out error and this value of 1. So if I run this here, you're going to see that I do indeed console log out error with the value of 1 because this rejects, and I enter this catch block here. And then regardless of the situation, I'm going to keep running this finally block, whether a promise resolves or rejects. So async await in JavaScript, an async function is a function declared with the async keyword. And the await keyword can be used only within async functions, and allows you to pause your async function until some promise either resolves or rejects. And once you pause your function, you're going to continue to run all synchronous code throughout the rest of your program. But then once that promise resolves or rejects, you're going to come back into that function and you're going to complete the running of that function. Now, async functions, they always return a promise. They will wrap their return value within a promise no matter what. And you can handle your async function kind of resolutions and rejections by wrapping your logic within try, catch, finally blocks to handle some different errors and things like that. So hopefully this video gives you a good understanding of how async await works within JavaScript and that you took something away from it. So I appreciate you tuning in, and I'll see you in that next one.